Okay, June 2011, question 4 of the Edx M3 paper is a question on horizontal circular motion, and it's one of these questions with a mass attached to two strings. Take your time to read the question and carry on playing with the video when you're ready. Okay, here's the diagram then, and I've done the resolving equations simply to save some time on the video and to give you a chance to look at them. So pause the video and have a look. Let me draw your attention to the angles first of all. We've got a 45-degree angle for this string because of the distances 3a and 3a. I've called this angle theta, and we know sine and cos and tan of theta because 3a, 4a, this side would be 5. Here's the triangle, 3, 4, 5. So sine theta is 3/5 and cos theta is 4/5. Pause the video, have a look at those resolving equations and satisfy yourself that you're happy with them. I've resolved vertically because there's no acceleration vertically, so the forces balance. Horizontally, towards the center of the circle at C, the total force, the resultant force towards the center is equal to, well, either mv squared over r or mr omega squared. And we've used the second of those two since they tell us about omega. Right, so putting some numbers in here then, we've got 4/5 t1 equals root 2 over 2 t2 plus mg, and on the line below we've got 3/5 t1. Let's move that t2 term over the other side, and then we'll get minus root 2 over 2 t2 plus 3m a omega squared. Adding them up now, then we get 7/5 t1 equals mg plus 3m a omega squared, and that's looking hopeful because that gives us t1 equals 5 over 7. Well, it gives us what they want. 5 over 7 into, let's take an m out as well, 5/7 of m into 3a omega squared plus g. So that's T1, the tension in AP. All we have to do now is go back into the two equations above and find T2. So you might like to pause the video again and work out T2. I'll go through it on the next page then. So T1 I've written down again up here. T2 will be 4/5 of T1, which is 4/7 m 3a omega squared plus g, minus an mg there, and that's root 2 over 2 t2. So when you unscramble all of this, making the minus mg term 7 over 7 mg, you get 1/7 of 12 m a omega squared plus 4 mg minus 7 minus 3 mg. Right. We can take a 3 out of that, so we get 3 and an m, 3/7 m into 3/7 m into 4a omega squared minus g, and that's t2 over root 2. Let's write that as instead of root 2 over 2 is the same as t2 over root 2. So finally that gives us t2 equals 3 root 2. I go up the top here then, so I'm running a bit short of space. T2 is 3 root 2 m over 7 into 4a omega squared minus g. A bit messy, but we got there. That's T2 then, the tension in BP. And there's one more part of the question, part C, if I just draw your attention to it here. Deduce that omega is greater than or equal to that expression. Now, the faster this goes, the greater omega is, the more tension there'll be in the strings. And more to the point, if omega drops below a certain level, there's a risk that one of the strings goes slack. We're told that both strings are taut. In the original wording of the question, both strings are taut. Now the string that risks going slack is the string BP, the lower string. So we know that BP has got tension in it. So we know that, this is for part C, I've just got room to fit it in because it's only short. We know that T2 is greater than 0 after all of that wordy explanation. T2 is greater than 0. So looking at T2, that means 4A omega squared is greater than G. That bracket must be positive, which gives you omega squared is greater than G over 4A, which tells you omega, just got room to fit that in, is greater than 1 over 2. Now we'll think about the greater than or equal to in a minute. 1/2 root G over A. So that's that expression. Now, if we made this greater than or equal to 0, it would mean the tension in the string BP was just coming to 0. So it was on the point of being slack. So I suppose justification for having, we could have greater than or equal to 0 there. Greater or equal to, greater or equal to, greater or equal to. That's the critical value when T2 is just coming 0. And that gives the answer they want for part C. For the marks for this question, just going back to the first bit. Okay, for the resolving, first of all, there was method and accuracy marks for each of those, M1A1 and M1A1. And that's half the marks, half the 8 marks for this part of the question. There was a B1 up here as well for the values for sine theta and cos theta. So for finding T1, 1, 2, 3, 4, 5, there's 3 more marks for that. There's a method mark and 2 accuracy marks then. So the method mark for solving the equations, an accuracy mark for putting the correct values in the equations, I think the 4/5 and 3/5 and root 2s, etc. And an A1 for that. Does that give 8? 1, 2, 3, 4, 5, 6, 7, 8, yeah. Okay, so that's the first part. For the second part, find the tension in BP. 2 marks, just 2 marks for that. So there was an M1, A1 for that one, working out T2. And for the very last part, another 2 marks, isn't it? For the last part, yeah, an M1, A1 for that there. Okay, I hope that was helpful. Thank you for listening. That's June 2011 question 4 done.